Let us look today at quadratic functions. Our objective is to graph a quadratic function in the form of y equals x squared plus bx plus c. Now, in that quadratic function, the value of b affects the position of the axis of symmetry. So we can say all these different terms do have an effect on our parabola. Like for instance, our a term, it'll indicate if our parabola points up or if it points down. It'll indicate if our parabola is narrow or if it's wide. It'll tell us if our parabola has a maximum or a minimum. Our c term affects our parabola in the sense of it moving up or it moving down on the graph. But we are going to look at the b term today and how that influences our parabola. And what it's going to do is it's going to affect the position of the axis of symmetry. So let's take a look at how it might do that, and this ends up playing out as a ratio. Okay, so when we look at these particular graphs here, so there's their equation, and then there's the parabola. Now, if you notice that the axis of symmetry changes with each change in the b value, so let's keep an eye on that. The equation of the axis of symmetry is related to the ratio b over a. Now, the axis of symmetry is not b over a, but it is related to it. So let's take a look. So the equation of y equals 2x squared plus 2x, the ratio of b over a, or 2 over 2, is 1. And this axis of symmetry is actually at negative half. When we look at the second one of our equation, if we have 2 and 4, now we change the b term. We change the b term from a 2 to a 4, and you can see that it does adjust our graph. Now notice our parabola here, the size of it doesn't change. It continues to point up because that's what the a term is doing, but the b term has shifted it. It almost moved it at an angle, like shifted it downward, and it looks like it keeps continuing to shift it more of an angle from the origin. So let's pay attention to what that's doing. So let's come back to our equation down here. So we see that it's the a term is 2, the b term is 4, the ratio 4 over 2, which is 2, and our line of symmetry is at negative 1. Let's look at the third one, and hang in there if you're not seeing the connection yet. So we have 2 and 6. So a term is 2, b term is 6, and that's a ratio of b over 2, which is going to get us 3. And our ratio, our axis of symmetry actually is at negative 3/2. And if you can kind of take a look here, we're noticing that there is a relationship playing out here with the 1s and the 2s and the 3s. And then if you notice, the 2 playing out here is a 2 that is playing out in even in our equation. So the equation for the axis symmetry is this. It's 1/2, negative 1/2 b over a. Or this will be the more familiar one, the more common one we'll use, is negative b over double a. So negative b over double a. And we do this to be able to find our axis of symmetry. So we can start graphing our quadratic function. So why don't we try that out? So negative b over 2a. Define our ratio. So let's get started on this one here. Okay, when we're graphing y equals in this format, so let's take a look at this guy. Okay, so find the axis of symmetry. One of the first things I need to do. So I'm going to take my a term and my b term, and I'm going to go ahead and do that. So I'm going to find the negative of my b term, which is negative 6, over double my a term, which is 1. So negative 6, so that'll be 6 over 2, and that'll be 3. So I know that my axis of symmetry is going to be at 3. So if I'm looking at a graph of this particular thing, I know that my axis of symmetry is going to be where x equals 3. So it's going to be like right here. My axis of symmetry, and my parabola is going to be over there somewhere. And then I want to find 2 other points on the graph, so I can continue to graph this. So what I can do is, coming back to my original equation, y equals x squared minus 6x plus 4. If I just try where x equals 0, nice easy one here, 0 squared minus 6 times 0 plus 4, I can see that I will have a point at 0, 4. Another one I like to try is maybe where x equals 1. So I have 1 squared equals 6 times 1 plus 4. Whoa, something went awry. There we go. And so we have a coordinate at 1, negative 6 plus 4, so squared. We should have one at 1 and negative 1. And if we graph that out, we can see that our axis symmetry is at 3 right here. We can see that our vertex is at 3. In fact, let's go ahead and do that. Find the coordinates of the vertex. We can do that by plugging this in. So if x is 3. So I'm trying to find y when x is 3. So 3 squared minus 6 times 3 plus 4. Because if x is 3, this is going to play out where y is going to end up being negative 5. And that gives us our coordinate of our vertex, 3, negative 5. So that's one step I forgot to do earlier, as I found my axis symmetry, but I didn't find the coordinate of the vertex, which is going to be the minimum in this graph. And so when I plugged in x, I found out that y was negative 5. So when I plot it, I can plot that point. And I can also plot my other 2 points, which was at 0. What did I find? I found one at 0, 4, which was up here. And then I found a point at 1, negative 1. And then once I could plot my points, remember we did this in one of the other lessons, is once I knew this point, I could match it over here. 1, 2, 1, 2, make the point. I know this was 1, 2, 3, so 1, 2, 3, and I match the point from my axis of symmetry. All right, why don't you go ahead and try it. Now remember, a couple things that I did is I found the ratio, and then I used my formula to find my x term, my x value for my vertex, and then I plugged it in and found my y term, which gave me the coordinate of my axis of symmetry, and then I used 0 and 1, and you can use some other things too, to try to find 2 points, and then reflect them off of the axis of symmetry, and that'll allow you to draw your graph. Why don't you press pause and try it out. All right, in black I found my ratio, negative b over 2a. So when I did that ratio, I found 2, and what that gave me is that gave me my x value for my vertex. So then I went back to my equation, plugged in my x term to find my y term, and I found y equals 2. So 2, 2 ended up being the coordinates of my vertex. When I originally looked up here at my a term, I saw that it was a negative a term, so I knew that it was going to point down, and my vertex is going to represent maximum in my parabola. Then I plugged in the 0 and found out that if x is 0, y has to be 2, and I plug that in, and then I tried where x is 1, and I plugged that in my equation, and I found that when x is 1, y is also 1, and I plotted that. Because of my axis symmetry here, I knew that if this is over 1, this is going to be over 1, so I'll have a point there, and this is over 2, so 1, 2, there'll be 1 here, and so my parabola is looking something like this, representing my maximum at at 2, 2. Reasoning in step 2 of problem 1. Why do you think that it was useful to use the y-intercept as one point on the graph? I think it just allows us to plot a point. It goes really quick and easy too. Nice and quick with that one. All right, I'm going to go look for my cousin and see if I can pinch his nose and have him sing a funny song.